Right, so it's Berkeley time, so we can go ahead and get started. Today we're going to be talking about building tables, and then for the second part of lecture, we'll be talking through an example. Yeah, so I'll try to give you all like a 5 to 10 minute break in between the two lectures because I know sitting through a 2 hour lecture can be really tiring. Yeah, so let's go ahead and get into some announcements. So homework 1 is due tonight at 11:59 p.m. And also make sure that you are submitting your file to Gradescope and you're submitting the correct file. I think we've seen some issues where you think you might have submitted it, but it's not the most up-to-date version, or you're submitting your lab zip into the homework one. So just double check. I know it's kind of overwhelming to already have a homework assignment due. But yeah, just double check just for the sake of peace of mind. And then homework 2 will be released after lecture and due on Tuesday at 11:59 p.m. Lecture section, tutoring sections, office hours on Monday are all canceled due to the university holiday. And then for lab 3, we'll be releasing that on Saturday, and that will be due on Tuesday as well. And of course, we're going to be having extra office hours on Tuesday and the rest of the week. So hopefully no class on Monday doesn't throw you off too much. You could check your submission on Gradescope and just make sure that the auto-grader tests that you think you passed in your notebook are passed and that you submitted the correct file. Yeah, so we'll be uploading the lecture for Monday, a recording, as well as the discussion walkthrough. So highly recommend that you watch those before lecture on Tuesday. So we're not actually going to have a lab section. I know a lot of you like having that extra help in a lab section, but we're going to have extra staff in office hours. So hopefully you can still have time to get the lab done. Okay, so going over our weekly goals. So yesterday we did types of data and arrays. And today we're going to be talking about how we can create new tables, manipulate columns of tables. And then after we get some of that table manipulation stuff covered, we'll be working with some census data as well. And I also wanted to quickly go over like the motivation for why we're doing all the stuff that we've been doing this past week. So I know individually just looking at an array or looking at like the different types of data, it's hard to see the bigger picture of why you're doing all that stuff. But I think in this lecture, you can see that you can chain functions together and find a lot of interesting information based on like different data. So of course, you can take this stuff outside of this class and work on data sets that you're particularly interested in and use all these different functions that we learned on that as well. Okay, so let's go into a review of arrays. So really quickly, remember to always run the first cell at the top of the notebook. So let's go into arrays. So like we saw last time, an array is a sequence of values and it's going to be values all of the same type. So for example, if we wanted an array of ints, we can do array, or let's call this my array. And if you remember, we can make a new array by saying make array. And then let's just make this 1, 2, 3, 4. And then what does that look like again? Okay, so now we have this array and you can do, so each one of these values here, we can call that an element. So we can also do mathematical operations on these elements. So for example, if you did my array times 2, you would get an array like 2, 4, 6, 8, and you would multiply all of these values here, each individually by 2. So something else you could do is you can find, so let's say you want to know how many elements there are in this array. You can use this function called len, which is you can think of as length, and check my array. And so if you just look individually at these values, you can count that's 1, 2, 3, 4 values. So you would expect this length to say 4. And then something else you can do is sum up all of the values in the array. So my array, and that's 10. All right. And then another interesting thing that you can do with arrays is find the average of an array. So if you remember, taking an average is taking up the sum of all its elements and dividing that by the number of elements. So we've already calculated some of that stuff above, right? So we've calculated how to find the sum of all the elements in the array and how to find the number of elements in the array. So if we run that, you can see the average we get here is 2.5. And just a reminder that even though we did my array times 2 over here, my array still looks like 1, 2, 3, 4. Okay, and then there's actually an easier way that we can calculate the average rather than manually finding the sum of all the elements and the number of elements. There's a function called np.average. Let me do my average of my array. And that you can see that gives you the same result. So you might be wondering why we have this little np dot thing over here. So I'm going to talk a little bit about this import statement up here. So basically, there are a lot of functions that are built into Python. Like I think we saw the past week, we saw abs, we saw min, we saw max. So those are functions that are built into Python. But then there are other functions and stuff that other people have written in order to make your life easier when you're working with stuff in Python. So for example, the data science module is something that the creators of this class created specifically to work with tables. And so that's all of this stuff that we've been doing. So for example, make array is part of that, and all of the table stuff is part of that. And then NumPy is another example. It was written just to make a lot of these operations easier and faster. So it's really, NumPy is really popular to use when you have large computations to make. So you don't have to know too much of these details. I just wanted to quickly talk about that. So that's why we put np.average here, because we're hinting, or we're telling Python that we want to use the average function from the NumPy package. Yeah, so that whole segue was like a little bit confusing, but just know that you have to use np.average. So if you wanted to do average of my array, that wouldn't work because there's no built-in average function. So you have to do np.average. Okay. There are no questions in the chat. Does anyone have any questions? Yeah, so right here, we're importing NumPy as NP. That's saying we're importing NumPy functions as NP. So whenever you're using a NumPy function, you're going to use NP dot and then the name of the function. So that kind of distinguishes some functions between functions in NumPy and functions that are built in. You can add a cell by clicking this add button up here. Yeah, so NP is just an abbreviation for NumPy. So if you didn't like include this part, you would have to put NumPy dot average. Okay, so I think we saw last time as well that you can add together two arrays as long as, let's do another array. as long as the two arrays are of the same length. So let's do, I don't know, 70, 60, 90, 100. So this array looks like 70, 60, 90, 100. And so you can add together my array and another array. And then you get 71, 62, 93, 104. So that's what we were expecting. But let's say instead of the fourth value here, we just make an array of length 3. This would error because we can't put two shapes together that are of different lengths. Okay, so far we've been working with arrays with integer values. So what if we did an array of strings? So what would that look like? So let's do tunas equals make array. I'm gonna do bluefin. And then this last one is an office reference. I don't know if anyone caught that. I can't take credit for that. It was a past instructor for this course, Professor Tsai, but yeah. Anyways, so tunas looks like this. So you can see each individual string is an element in this array. And above we saw that we can multiply and do a mathematical operation to that array, and you can get all those individual elements multiplied by that value. So let's see what happens here. So if we just did bluefin and we multiply that by 4, you see bluefin 4 times. So that all aligns with what we've seen so far. But what if we try to multiply this whole array by 4? Okay, so that actually doesn't work. And that's just because of the way this is written. You can't do those mathematical operations on each one of these elements. So just be mindful of that, be careful. And if you're unsure about something, always you can always open up a Jupyter notebook and try it out and see. If I multiply by 3, will that work? Okay, I think, yeah, so that also doesn't work. So the reason why 4 doesn't work isn't because it doesn't match the length of this array. It's because we can't multiply an array of strings and by 4, or you can't multiply it. You can't do those types of mathematical operations that you could do with int arrays. Yeah, but that's a great question. Okay, and then, so let's look at tunas again. So you have bluefin, albacore, and Jim. So what if you wanted to use the string albacore somewhere, but you don't want to type that all out again? You want to just grab it from the array. So you can do that by we call that indexing. So you do tunas.item. So this is a new function as well. And then the argument for .item is going to be an int value representing which index you're trying to grab. So for example, if we wanted to get bluefin, we could do .item 0, and that gets bluefin. So you might be wondering why we have to do 0 to get bluefin and not 1. That's because in Python, we do what's called zero indexing. So every time you want to reference an index of something, so each one of these values in the array has an index value. So that index value is going to be 0 for bluefin, 1 for albacore, and 2 for Jim. And so we start off counting at 0, and that becomes kind of just the convention for what we're doing here. So if you wanted to get the first element of this array, you would have to do .item 0. And then if you wanted to get, for example, albacore, you have to do .item 1. And then what do you think would happen if we did .item 3? Yeah, exactly. It errors because it's out of bounds. because like we said before, bluefin is 0, albacore is index 1, and Jim is index 2, and then the array ends. There's nothing at index 3. So that's why if we try to do .item 3, we get an error because there's nothing there. So a lot of times you might see this error. You can try to remember that might be because there's nothing at the end of that array for you to reference. Okay, I'm gonna pause there for any more questions. Let me check the chat. Oh, dtype U8, this part, that just says that that's a string. .item on a list. That's a great question. We don't work with lists in this class. So it's a little bit out of the scope of this class. Or for just right now, we're not going to be doing lists too much. So you actually shouldn't be using .item on a list. You would have to do, so this is just for those of you who know what I'm talking about when I say list. To index into the list, if you did like LST, that's the name of your list, you can index, if you want the first element, you can index by doing the brackets and then 0. But don't worry about that. In this class, you should be using arrays and .item. All right. Okay, so now let's go over how, now that we have arrays, now that we know how to work with arrays, we can do things with arrays in the context of a table. So let's look at the NBA table again. Oops. NBA dot. Actually, let me read this in real quick. And we'll go over how to load in tables in just a second. Okay, so we have the NBA table, and oops, sorry. Okay, so we have the NBA table, and what we can do is let's just get a table with only the team Warriors in here. Let's do NBA dot. And then as I'm kind of typing this, you can kind of think of what function we should be using here. So for example, right now we're going to be getting a table with only the players that are Warriors. So that corresponds to only the rows where those players are Warriors. So we can do that with .where. And the column we're going to be looking at is team. And that's Golden State Warriors. So you can see what that looks like. Okay, so now we have this table. So this is all stuff that we've seen before. So how does this correspond with arrays? So before, if we wanted to, for example, select just the salary column of the table, you could do warriors.select salary. And so what we get is a salary where a salary column of the table. But if you look, let's do salaries. But if you look at the type, you can see that salaries is a table, right? So something that we might want to do is we have all these values of salaries. Maybe we want to find the average value of all of these salaries. So if we try to do np.average here, this doesn't work because basically what's happening is salaries is a table and you can't find an average of something that's type table. But if you remember before, we took the average of an array. So one way, let's do this again. So warriors looks like this. So something we can do is called dot column and then use salary again. So that basically gives us the same value. So let me type salaries again so you can see. So these values are the same as these values. The only difference here is that this is an array, whereas this is a table. So they look similar, their values are the same, but the difference is that this is an array and this is a table. So now you can do np.average. Okay, so I want to stop here and just let that all sink in, because this is something that's commonly confused, the difference between using dot column and using dot select. So the difference is that dot select gives you back a table, whereas column gives you back an array. And you can also select multiple columns. And yeah, so using select, you could select multiple columns to make a new table with just those columns. But if you were to only select one column, if you use select, that gives you a table. If you use column, that gives you an array. So using dot column could allow you to do different mathematical operations on that array. Okay, seems like some people stopped following. Let's go back here. Okay, so 3, I think people are confused up here by what that means. So we're going to be going over how to relabel something in just a second, but 3 basically refers to the index of the column. So like we saw before, you can index these arrays. So this is 0, 1, and 2. You can also index into these column labels. So player would be column 0, position would be column 1, team would be column 2, salary would be column 3. So basically what we're saying is this column used to be something different, but I wanted to relabel it into salary. And so we're going to be taking the third column here and relabeling that to salary. But yeah, we're going to be doing that in a second. So where keeps all of these rows the same? Like all of the values that correspond to one row is going to stick together. What where does here is that it only gives you the rows where this is true. So if you go back, let's go back to what MBA looks like. So if you go back, the tables look different because this is a lot of these players are on a different team. If we wanted only the players that are on the Golden State Warriors, we did NBA.where, and now we have the team with only the rows where this is true. Is there a way to cast a column to an array? Yeah, so instead of casting things to, or instead of casting the column into an array, you're grabbing the column array from that table. So you can kind of think of that as a similar thing. So you want this, and you can also, let's do warriors.select salary. So you can see that's the salary table again. And if you wanted this into array format, you can do dot column again on that. And I'm about to go into with column. You can't load the tables consistently. I can try to get to that during the break. So in this class, we're going to be doing np.average for the average. Yeah, so where is basically filtering out all the rows that you don't want and just keeping the rows that you do want. Yeah, so let me pull up the Python reference sheet really quickly. So I know I'm going over a lot of different methods, and it gets really, really confusing, keeping track of every single thing that I've mentioned. So this web page right here is like the #1 opened page that I used when I was taking the class. It was really useful. You can see it shows you how to use select, what it does, what you input, what it returns. Yeah, so I know it's really confusing. I'll also like pause and go over all the functions we learned one more time, but while you're working on stuff, I definitely recommend looking at the Python reference sheet as well. Yeah, so select extracts columns, whereas where meets a condition and only selects those rows that meet that condition. Okay, I'm gonna let you all answer each other's questions for a second. Okay, so we saw we can do the average of the salary column. We can also do this again and do MBA dot. Let's find, we can also find all the NBA players where they're on the team. Lakers. My family's a Lakers family, so let's look at that. And then what we can do here is name that Lakers. And then what we can also do is we can find the difference between the averages of the salaries for the Warriors versus the Lakers. So we have up here, we found the average of the Warriors salaries. And then we can also do the same thing, but instead of Warriors, we look at Lakers. Yeah, I applied dot column because we want to get an array. So I was showing you that because select gives you back a table, you can also apply dot column to that afterwards, but that's kind of an extra step with selecting it. So it's easier to just directly do dot column. Yeah. Okay. Yeah, I know this stuff is all really confusing. So let's just go back and sum this up again. So an array contains a sequence of values. All elements of an array should have the same type of value. The arithmetic is applied to each element individually. And then you can add arrays if their elements are of the same, if that array, those two arrays are the same length, and that just adds up those elements. And then a column of a table is an array. And so you can see we used functions like, we use functions like dot column to get the column of the table in the format of an array. You can use select to get columns of a table, but that just gives you a copy of the table. Okay. I'm going to pause again for questions. Yeah, so I'm going to get to some of these questions again after we cover ranges. So we're going to cover ranges, and then we're going to go over ways to create a table. So that'll kind of hopefully answer some more of these questions. All right, so basically a range is a special way of getting a sequence of arrays, and you can see that this will be easier to work with. So let's, for example, let's say I wanted to make an array that starts from 0 and goes all the way up until 6. Okay, so we have this full array, but even just going up to 6, that took me a really long time to type. I don't know about you, but I like to minimize the amount of typing I have to do whenever necessary, and it also really saves time. So there's something else. This is a new function it's called np.arange. And if we did np.arange 7, that actually gives us back that same array. So when you're doing 7, it's kind of harder to see the purpose. But if, let's say we wanted like all the numbers from 0 all the way up, but not including 100, you could do np.arange 100, and then that will give you all those values, and you don't have to type out all 100 numbers. So to sum up, what np.arange does is it creates an array for you, and it starts with 0, and it goes up to but not including that number that you inputted, and it does so with a step size of 1, meaning that it increases by 1 every single number. So there's actually a few ways you could do np.arange. So this first way is using just one argument. So if you just put one argument in here, that signals to Python that we're automatically going to start off at 0. So by default, if you only enter one number, it defaults to starting at 0 and a step size of 1. So let's say instead of starting at 0, you wanted to start at 5 and go up to 12, up to but not including 12. So that's also another important thing. This ending number here isn't included when you want when you get that final array. It's all those numbers up to but not including that number. So you can see we start with 5, so we go 5, 6, 7, 8, 9, 10, 11, so up to but not including 12. So if you have two numbers here, that means we're starting at this first number, and then we're ending at the number like right before this one. And again, by default, our step size is going to be 1. And then we can also do this with 3 arguments. So we can do np.arange. Let's do 0, 20, and 2. Okay, so when we do that, you can see how each time we increase, so we start at 0, we go up to but not including 20, and each time we increase, each time we increment, we get a step size of 2. So you can see that's difference of 2, 2. These are all differences of 2. So yeah, I think someone in the chat put np.arange start, end, and step. So that's exactly right. The first number is going to be the number you start with. The second number is going to be the number that you end with, but it won't include that number. And then the third number is going to be the step size. So if you have all 3, it's going to treat all 3 as those. If you only have 2, it's going to assume that the step size is automatically 1. And if you only have one number in the argument, that assumes that you're going up to but not including that number and starting at 0 with a step size of 1. Okay, so got some interesting questions. What if you give arange a negative number? So let's do, yeah, so I don't think you'll get what you're expecting to get if you do that. And then let's see. There was another question here. Yeah, and then we can also increment this. Let's do 0, 1. And you don't actually have to put an integer value in here. You could do up by 0.1, and then that'll give you 0 up to but not including 1, and then increments of 0.1. So what if we're looking up here and you want to include 20? So you want all the even numbers up to and including 20. How can we fix this? Yeah, so I see in the chat 0, 21. So that includes 20. You can also do 0, 22. And that would also include 20. But you can go up to like 25, because then that includes numbers that you might not want. And yeah, you can do odd numbers. So we could do odd numbers. So if you start with an odd number and go up by 2, that'll give you odd numbers. And then someone else is saying you can do np.a range of negative numbers. Oops, sorry, did not copy the correct thing. So if you wanted, let's say negative numbers going 0 all the way to negative 20, but not including negative 20 with increments of negative 2, you could do that as well. Yeah, great point. Yeah, so just to reiterate, the first number, let's go to an easier looking thing. The first number is what we start with. The second number is what you end with, but it's not going to include that ending number. And then the third number is going to be the step size that you have. Okay, yeah, these are all great questions. I'm glad everyone's really engaging with the content. Yeah, okay, let's go back to the slides. Okay, so we saw ranges. So a range, again, is an array of consecutive numbers. You're going to have, let's go through all these. You're going to have a start, an end, and a step. So if you only have one argument, that's just the ending number. If you have 2, that's the start and end numbers. And if you have 3, that's start, end, and step. Let me open the chat. So the range always includes start, but excludes end. So I think this is also something that people commonly forget. I know I forgot it a lot too, is that it doesn't include the end. Okay, so now I know there's been a lot of questions on how you can create a table. So in this class, there's 2 ways that we like to create tables. One is to read in that table with a CSV. So a CSV or like a spreadsheet is, here I can show you an example. So this is an example of the NBA salary CSV that we were working at earlier. And then I think you and I went over that earlier. It's basically comma separated values. So you can see how the names of each column is the first line here and is separated by commas. And then all these values below are also separated by commas. So we're going to be importing that spreadsheet in to read that in as a table. And then table like this just creates an empty table. And there are a lot of other things you can do to create new tables. So let's go into that. So first, let's just try to create a table from scratch. So I'm going to create a table. We're going to call this streets. So I know a lot of you haven't been to Berkeley yet, but if you are familiar with the Berkeley campus and you've been on Southside, you'll recognize these street names. So let's make an array of different streets in Berkeley. Let's go Bancroft. I think the next one is Durant, then Channing, and then Haste. Oops. And then let's look at what that looks like. Okay, so looking at that, you get an array of these 4 values. So that's what we were expecting because we're making an array here. And so let's say you want to put all those values into a table. So we can do that. So table, like we saw earlier, table like this, just creates an empty table. Now there's nothing there, so that's why you just get something blank. But if we wanted to add this array into a table, what you can do is start off with table with those parentheses. And then the way you add a column is to do with column. And now, so this is also a new function. So you do with column, and then the first argument here is going to be the name of the new column that you want to do. So let's call this streets. And then the second argument is going to be the values, the array of values that you want to be in that column. So in this case, we want these values to be in that column. So we're going to put streets here. So now you can see we have a table where the columns, where the one single column streets has these values that we had up here. So let's call this south side. All right. So now we've created a table and we've added the column streets. What if we wanted to add another column? So let's add south side with column. And now, you know, maybe I want to give a map to someone who's never been on campus. You want to tell that person how many blocks each of these streets are away from campus. So we can make a column. Let's call this blocks away. And so Bancroft would be 0 blocks away, Durant would be 1, Channing would be 2, and Hayes would be 3. How can we add in an array of values here so that we get 0, 1, 2, and 3? Yeah, exactly. So one way you could have done it is make array 0, 1, 2, 3. But since we just learned about ranges, it's a little bit easier to just do that, a range 4. So now you see this is the array of values that we're inputting. So that's going to look like 0, 1, 2, 3. And then we added this column. So this is the name of the column and these are the values. So now you see we have the south side column, or south side table, I mean, south side. So now we have the south side table with one column with each of these street names and one column for the number of blocks away from campus it is. Okay, so what if you want to just add multiple columns all in one expression and you don't want to do with column a bunch of times? So you can do that as well. So what we're going to do is table with columns. So this is almost exactly the same, but the difference is that this is with columns singular and this is with columns plural. And that kind of makes sense, right? Because we want to add one column here, whereas here we want to add multiple columns. And so let's do streets. This is going to be streets. And I'm actually going to separate this into multiple lines just so that it's easier to read. And then np.arange 4. So now you can see you get that same column back, but, you get that same exact table as we had before, but the difference is you can just do this all at once. Okay. Let me look for questions again. I know this is really confusing. Is there with row? That's a great question. We're actually not going to be doing anything where you do dot with row. There's a way you can add together two rows or like two tables, but I think we'll see that a little bit later. Can you add a column before another one instead of after it? So do you mean like you want, let's say, like common living areas? So this would be like something on Bancroft. So like Blackwell, unit 1, unit 2, unit 3, stuff like that. You want that before. Yeah, so you can so what you can do is if you have two different tables and you want to add that together, we're actually going to be going over that in a future lecture. Let me make sure I'm getting everything. It doesn't matter if you use single quotes or double quotes for the names. And then why do we add streets after the string streets? That's a great question. So this right here is, so this is the name of the column, and this is the array of values that you want to input. But as you can see below here, it doesn't have to be the same name as what you're labeling it. So I labeled it like the same thing because it's a little bit easier to understand what I'm doing, but you can also do something like blocks away, and this variable doesn't have to be like blocks away. It could be any array of values like we have here. Yeah, so you can also add that columns after this, and then if you want to add columns before, you can rearrange the order that you input the table columns, or later on in lecture, we'll be learning a way to combine two tables together. Yeah, that's a great question. You can add a single column using with columns. So if, for example, you just wanted to do one, you could do that as well. Yeah, let me show the table creation again. So what we did is we did table. So table just creates a table, but that table doesn't have anything in it, right? So you can see up here, there's nothing in it. And so what we want to do is as soon as you create that table, you are going to be adding a column to that. So we're going to create that table and add a column here. So that's what you can see here. Yeah, so let me name this something else. So instead of streets, let's name this just Berkeley. So you can see we get that same array. So this is the array of values that we're inputting, and this is the name of the column. So you can see you get the same one, but you don't need to name this variable the same thing as the column label. Yeah, it's definitely confusing. All right, and then I think before we go on a break, let's try reading a table from a file. So a lot of you filled out the welcome survey. I know homework 1 is due today, so you might not have gotten to that yet. But on the welcome survey, there was a lot of interesting information, and we anonymized it and randomized it and a lot of other stuff. So what we can do is we have, let's read in a table. So this is read table. So this is the other function that we were talking about here. So you could do table.readTable, which reads a table in from a spreadsheet. And that spreadsheet was called welcome survey.csv. And I'm actually going to just drop the first column because we don't really need that. So you can see there's some information here about time zone, the scale that you put for extroversion, information about how many people you text, and then how many hours you feel like you sleep on average and your sleep style. So the first way we learned how to create a table is just from scratch. You enter in arrays of different values, and then you just put those arrays of values into columns of the table. And the second way is to read a column in from a file. So if you already have collected all this data, you don't have to manually write out what every single array is and put that into a table. You can just directly import that from a CSV. Okay, so it's 10:59. I'm gonna pause for some questions, and then we can take a break. Oh, that's a great question. Why did I put drop 0? So let me just show you what this original, oops, sorry, didn't mean to do that. Let me just show you what this table looks like to start off with. So this table, when I imported it, so when I was working with this CSV outside of this notebook, I accidentally included this unnamed column here as like the indices. So since that's not really relevant information, we're just going to drop that. Was this one cell that just said table necessary to create the south side table? That's a great question too. So this cell isn't necessary to create this table, but saying table here before adding with column is. Yeah, sorry, going back to this down here, we're dropping 0 because that's the first column and the index is 0. Yeah, so the drop 0 isn't necessarily needed in this case. So you can import a file and just keep all of the columns. I just dropped that column just for the sake of readability. How do you take multiple lines in a table? So if you wanted to take multiple rows, the same way you can take multiple columns, you can do, let's go back to this table. So south side, oops. So we have south side, and let's just say you wanted to look at Durant. You can take, and then this is also indexed in the same way the columns were indexed. So this is the 0th index, this is the first index. So you can also just take that one row. Yeah, so let me finish up the questions about the table itself. Oh, there's a great question where if you're making the table with columns and all the arrays have to be 4, would it work if only one of those arrays had 3 elements in it? So that's a great question. So let's look at this again. So south side is a column with just one column with all the street names. So let's say instead of box away, mp.arange is 4. And let's say we just forgot that it starts at 0 and goes up to but not including 4. Let's say that we thought, oh, we need to include 1 and go up to 4. What would happen? So that doesn't work because we get a column length mismatch. So that new column has to have the same number of rows as the table. So that array that you add in has to be the same length as the previous array. But yeah, that was a great question. Yeah, there's also a question, can an array have none or null values? Yeah, so you can have an array of values that have like different integers, and some of those can just be null. That would work. And then if you were to drop 1 instead, that would drop time zones, yeah. Okay, I'm going to give you all a break now. So let's come back. Let's take a 7-minute break and come back at 11:10. There was a question in the chat that says, does take and where mean the same thing? So that's a great question. So take and where do very similar things, but the difference is that, so let me find it here. So where takes certain rows based on a specific condition, whereas take takes certain rows based on the row indices. So you could do the same thing using where and take, but where saves you an extra step of finding all the row indices of the rows that you want to grab. So for example, if you saw the NBA stuff up above, we did .where the team for each of the players is Golden State Warriors. So if you wanted to do that using take, you would have to manually look through the table and see which indices those rows are on. So that's why it's easier to do where. Okay, so let's move on to an example. So now that we've seen a lot of the different table functions, we can go through an example. Indices is like, so what we're, everything here has an index. So for example, if you have an array, let me go to an array. So if you have an array here, each one of these has an index. So that's, actually, let's find one that, okay. So if you look at this array here, there are 4 values: Bancroft, Durant, Channing, and Haste. So within that array, each of these has an index value. So this would be indexed at 0, 1, 2, and 3. So the first value is going to be 0, and you're going to count up by 1. So yeah, it's like the position number, exactly. Okay, so we're going to get into some more interesting stuff with these table functions. So we have this information from the welcome survey. So let's just find out, discover some things here. So also before we do, I wanted to quickly say some things. So whenever you have data, it's always important to think about the context of that data, right? So looking at the number of rows, could anyone think of some issues with this data? Is it going to be representative of all students in data 8 right now? Okay, a lot of people are saying no. Could you maybe give some reasons? Okay, yeah, so maybe one of the reasons is that, yeah, it's self-selected data, so you chose to respond. Not everyone responded to all of the questions. Another thing is that the homework is due tonight, so a lot of you probably didn't even get to the welcome survey yet. So it might not be representative of all of you all because only the students that have already filled out the survey are included. And again, it is voluntary response. Yeah, so just some things to think about. Whenever we're working with data, we always want to think about and ask ourselves those types of questions. Okay, so first things first, let's look at side sleepers and how long that these side sleepers, that's a tongue twister, may sleep on average. So whenever we're doing stuff with tables, it's always good to like kind of write out the different steps of this. Yeah, and then someone else said maybe time zone is related to whether or not you've completed the homework. Yeah, there's a lot of interesting things you can do with this stuff. So on average, how long do side sleepers sleep? So one thing we want to do with that is that the first step would be to isolate only rows that are side sleepers. So you see a lot of people here sleep on their backs. So we want only the rows where they sleep on the right side or the left side. So how can we go about doing that? Yeah, great. I see .where in the chat. So let's do this table. Actually, make sure to name your tables. That's called welcome. Okay, so how long does side sleepers sleep? First step, isolate only the rows that are side sleepers. So let's do welcome, which is the table that we're working with. And we want to do .where. And the column that we're looking at here is sleep style, right? Because we want to isolate only the values that have on your right side or on your left side. So we're going to be looking at the sleep style columns. Let's do sleep style. And then this is something slightly new, is before we saw something where you would do where and then something that was exactly the value that we're looking at. But in this case, you want on your right side and on your left side. So we can use something that's called a predicate. So we're going to do r.containing side. Okay, And then really quickly, I'm going to go back to the Python reference sheet and show you that there are a lot of different where predicates you can use. And here's a good list of them. And so we're using R containing S, so that means that it contains the string S. So we're looking for all the values where the sleep style contains the word side in this string. So if you look here, you get values of on your right side and on your left side, and then we've excluded all those values that are on your back. And then that's the first step. So I'm going to write side, assign this to side. Okay, so now what would be the next step? So after you have all of those side sleepers, what are we actually looking for here? Yeah, we're looking for the average hours that those side sleepers slept. This is like a new tongue twister. Okay, so we want to get side. Let me actually write out the step. So another thing that I'm doing here is you notice I'm using this pound symbol and then writing out kind of details for how we're doing this. So that's what's called a comment, and comments are really useful, especially when you're trying to think through your code, or if you want to share your code with someone else, you can comment and describe what you're doing. And it's also useful if you're looking back at your homeworks later on and you're trying to figure out what exactly you did. Comments can be really useful. So the second step, find all the hours slept values. So we can do that by Tsai.column hours sleep. And before I hit Shift Enter and run the cell, could anyone tell me what type this will give us? Exactly, it'll give us an array. And then now that we have an array, we can take the average of that. Yeah, so it looks like people who sleep on their sides average a little over 7 hours a night. And that kind of makes some sense. But, you know, we've been taught, you know, at least 8 hours of sleep is good. So let's find out how many students get at least 8 hours of sleep each night on average. So let's not focus on the how many students part yet. Let's focus on how we can get all the students where they get at least 8 hours of sleep each night. Let's do welcome. So you want all the rows where they, yep, we use .where. And the column we're looking at is hours of sleep. So we're going to do hours sleep. And then we need a predicate here, and we need to know at least 8 hours of sleep. So if you're not sure, you can go back to the Python reference sheet, and it looks like, oh, R above will be good to use here. Or at least means greater than or equal to, right? So above or equal to. And then in parentheses, you're going to be putting the number that you're looking for. So now you can see everyone who put their average number of hours they sleep. And it looks like all the values here are 8 or above, so that makes sense. And then what we can do to find the total number is to do .num rows. And so you get 83. So really quickly, I want to go back to this table, and actually I might have skipped a little bit of steps here. So I think a good first step for when you get data is to find out some information about it. So some things we can do is we can do welcome dot labels. So that gives you the names of the columns of this table. You could do welcome dot num rows, which gives you the number of rows in the table. And you can also do welcome dot num columns, which gives you the number of columns in the table. So I think it's always a good first step. I know I kind of skipped and dived right into all of the more interesting stuff, but it's always good to know what data you're working with, what that looks like, how many rows there are, etc. Yeah, num rows ignores the headers and just counts the number of values or number of entries you have in this table. Yeah, sorry about that. I know I'm going a little bit back and forth here. So if you look at this gives you all of the people that sleep above or equal to 8 hours. So if you want to just count that up, you can do num rows. And then someone says, can we do len? Let's try that. Yeah, so I think someone mentioned here when we did length, we get 5, which is the number of columns we have. And then let's say we get the number 83, and it's not really too much information to just see like the number 83 without any context. So one thing that's good to do is maybe instead of finding the total number, we can get the proportion. So if you remember, the proportion is the number of people that of that specific interest divided by the total number, right? So how can we get the total number of people in the original table? Yeah, you could do welcome.num rows because that indicates the total number of people that are in the original welcome table. So you see that's 33%. So it seems like only 33% of you all are getting above 8 hours of sleep. Okay. So let's go back to 83. And there's actually a few other ways you can get this value. So I'm going to introduce another new function called np.countNonZero. But first, let's look at the welcome.column hours sleep. So remember, the column hours sleep is an array and it has values like this. And then something we can also do is check how many of these are greater than or equal to 8. And then what that's going to give us, it's going to be an array of the same length, which corresponds to whether or not that hour is greater than or equal to 8. Yeah, so something else to think about is maybe not all of you have filled this out completely honestly. So if you look here, you see 7 is not greater than or equal to 8, 5 is not, 8 is. So if you were looking to see which of these were greater than or equal to 8, you would say false, false, true, right? So you can see that here. So that was false, false, and true. So basically what this array is an array of true and false values. So those are what's called Booleans. And those are indicating whether or not that hour in that element of the original array was greater than or equal to 8. And so what we can do now is, I'm going to write here. So in Python, true evaluates to 1 and false is 0. Oops, false is 0. So if you count up, so what we're going to do is we're going to use something called np.countNonZero. So np.countNonZero takes in an array and counts up all the number of times that you get a non-zero value. So what that means is it's going to be counting up all the times that you get 1, which is also true. So this is counting up all the number of times this is true. And what true means is that that number is greater than or equal to 8. So you see that gives you the same value, but it's a little bit more complicated, a little bit more steps. And then you can also do a similar thing here, where instead of doing np.count not 0, you could np.sum. And that's because, let's look at this again. So like we said before, true is 1 and false is 0. So if you add up a bunch of zeros and ones, only the ones are going to be counted. So the sum of zeros and ones is going to be the same as the number of ones there are in that array. So that's why all 3 ways give you that same value. Okay, I'm gonna pause, let that digest. We're also going to be going over count non-zero, np.count non-zero again in the future. So if you don't get this right away, we'll be seeing it again. Is there a count 0 where you can check if it's under 8? We do not have a function called count 0. But if you did, what would be the opposite of something greater than or equal to 8? So let's say you wanted to find everything less than. Yeah, you could do less than 8. Yeah, exactly. Okay. So now let's do something else. Let's do a table. Let's create a table with only the 2 sleep-related columns, which are our sleep and sleep style. And that's also still like a little bit confusing. So we can also name it hours and position. So there are 2 steps we want to do here. One is to get step 1, only the columns, only the 2 columns that were listed. And then step 2 be to relabel them. So let's go to step 1. So does anyone remember how you can take only 2 columns from that original table? Yeah, select. And alternatively, you can also use drop and drop the other columns. So let's do welcome.select hours sleep and sleep style. Okay, so let's double check. Does this make sense? So we have the column hours sleep and sleep style, and it looks like those are the columns from the original table, so that seems good. So now that we have that, what we can do is relabel them. So like I showed you really quickly above, we can do .relabeled. And if we want to relabel this column, we can do this in 2 ways. The first way is to use the index. So if you remember, this is index 0 and this is index 1. So we want to relabel that to hours. So let's just look at what that looks like. So you can see how it was hours sleep before, and now it's hours with a capital H. And we can do that again. Oh my God, I can't spell relabeled. With index 1. So this first argument is going to indicate which column that we're relabeling, and the second one is going to be what we're relabeling it to. So this is going to be position. And you can also do this by, instead of the index, you can say sleep style, and that would also relabel it. Okay, and then the second way you can do this is, instead of selecting these ones, you would just drop the other columns in this table. Okay, now let's look at, on average, how many people do you all text in a day? So it's been a while since we've seen the original table. I've kind of forgotten what that table was called. So let's just look at the table again. So I think that column was called texting info. So let's just see. So if we wanted to, oh, let me look at the questions. Yeah, so sleep style. So when we relabel, there's two ways. So the first argument is going to be the column that you're relabeling, and the second one is going to be what you're relabeling it to. So there's two ways to tell Python which column you're relabeling. The first way is to look at the index. So ours was index 0. So you're saying, oh, we're relabeling the 0th column. And the second way is to relabel it based on the label of the original one. So let's look at what the original one looks like really quickly. So we've relabeled hours, and now we want to relabel sleep style into position. And so instead of doing dot column, or instead of using 1 here, we're going to refer to it with the name of the column, which is sleep style. And yes, there will be office hours today. I know there's a lot going on. Okay, so if we want to look at how many people text in a day, how can we find the average of this column here? There are kind of two steps that we've seen. Yeah, you make it into an array first. So how can you make this column into an array? Yep, column. Yeah, exactly. Texting info, and then you want to take the average of that. Okay, so I think we've done the right steps here. We've taken this column from the table and we've taken the average of that. Does this value make sense? So as a reminder, this question is asking how many people do you text on average in a day? Yeah, I don't know about you all, but I text like 5 people in a day, maybe maximum. So this seems like kind of an absurd number. Like, I don't think I even know that number of people. So yeah, that's just saying that you should, this is just to show you should always like double check and ask yourself these questions. Does this make sense? Is this what I'm expecting? Yeah, so someone's suggesting you could check the max. So yeah, what you could do in this case is there actually are a few outliers in the data. I think some people just put in some fun numbers, so that caused a few outliers, which makes the average in turn kind of absurd. But yeah, so if you wanted to do that, you can check the max, and then maybe if you wanted to, you can remove that value as well, and then retake the average. Yeah, for the sake of time, I think we'll stop there with our example, but I will say that it's kind of fun to look at a table and ask yourself, oh, like, what can I find out about this table? Like, you can look at this table and find out what's the average number of sleep, like how many people like to sleep on the right side. There's kind of like an infinite number of possibilities you can like discover just using all this table stuff. So I know we've done a lot of different functions today, so let's just recap really quickly. So if you want to create a table or extend a table to add more columns, you can do table.withColumn, and to just read in that table, you can do table.readTable. To find the size of the table, you can do .numRows and .numColumns. And then if you want to refer to those columns, you can relabel them. So labels gives you the labels of the columns, and then relabeled helps you relabel those columns. And as a reminder, the column indices start at 0. And then you can also access the data in a column. So dot column takes a label or index and returns an array of those values in that column of the table. And then you can also use different array methods to work with the data in columns, such as you can take an item, you can do sum, min, max, you saw average a few times. You can also create a new table containing some of the original columns, like using select or drop. And then you can also manipulate the rows of the table a little bit. So dot sort, we haven't really seen dot sort too much, but you can sort the column of the rows in increasing and decreasing order. You can also take the row numbers. So I showed that a little bit today. So take is very similar to select, but instead of getting a table back with the columns that you selected, these are going to be the row numbers that you've decided that you want to take. So like we said before with the columns, each row has an index as well, and that also starts at 0. Dot where keeps only those rows that satisfy a certain condition. So before we saw column value, so that checks all the rows for which that column's value equals a particular value. So this up here with the condition is new. So it keeps all rows for which a column's value satisfies a condition, such as R above, R containing. And you can also look at the Python reference sheet for that as well. Okay, let me go through the chat again. Okay, looks like there's just some logistical stuff. So really quickly, I know we're kind of running short on time a little bit, but let's go. We've done a lot of stuff with like the welcome survey, but there's also another example we could do with census data. So really quickly, there are some discussion questions. So working with the MBA table, there are two questions here. One is to create an array containing the names of all point guards who make more than 15 million a year. And then actually, let's go back. Let's just start with this first question. So let's just read through and try to figure out what steps we need. So oftentimes it can seem really daunting to just see a question and have to jump right into coding something up. So what I like to do is kind of step through, figure out what steps we need. So reading it carefully again. So we want to create an array containing the names of all point guards who make more than 15 million a year. So we have a table called MBA. You want to isolate that so that you only have point guards and only those that make more than 15 million a year. And then after that, you want to grab an array from that table with only the names of those players. So looking at that, what do you all think that first step would be? Okay, yeah, you could also put the code in the chat, but just thinking out loud in plain English, what are the first steps that we want to do? Yeah, isolate rows of point guards. And then after you find only the point guards, what do you want to do that? Yeah, what will we want to do after we find only the point guards? Yeah, filter it so it's only those who make more than 15 million. And then after that, you have point guards who make more than 15 million. How do you get the array? Dot column. Yeah, exactly. So now that we've kind of talked through that, let's actually do that. So we have the MBA table. So the first step we said was to isolate only point guards. Let's do MBA dot where position point guards. And then after that, we want to isolate only point guards that make greater than 15 million. So we're going to do where again. And so what column are we looking at here? Yep, salary, and in all caps. And then we're not checking if it's exactly 15, we're checking that it's above 15, right? So we're going to be wanting to use r dot something. Yeah, so you can see here, we can use r dot above to find those values that are greater than 15, above 15. So also another thing to do is as you write out each step, it's good to just run the cell again and make sure that it's doing what you want it to do. So you can see it looks like these are all the players who are point guards and make more than 15 million. And then what's the last step? Yeah, get array of names. So in order to grab an array from this table, we're going to use dot column. And looks like it's the player column. And so yeah, now we have an array of names with all the players who are point guards and make above 15 million. So let's just double check, is this what the answer asked us to do? So we want to create an array containing all the names of the players. And so as long as we can check, it looks like this is an array of names. So I think we're good there. Okay. So yeah, congrats, you all got 100% on this question. And then after evaluating these two expressions in order, what's the result of the second one? So take a look. We do NBA.drop position, and then we want to look at number of columns again. So as a reminder, these are the 3 columns. Okay, so maybe if everyone can type in the chat how many columns you think will be an NBA. Yeah, it is 3. Okay, so let's just run that really quickly. Oops. So we have NBA.drop. What column are we dropping here? Position. Oh, whoops. Sorry. So this original table has 5. So I get why this question is confusing. So let's look at this original table with those 5 columns. If we drop position, it looks like there are only 4 columns here. But if we did NBA.num rows again, oh my God, sorry, not rows, columns, we still get 5. And that's because even though we dropped it, this actually created a new copy of that table. So if you look at NBA again, nothing has changed. So even though you dropped it here, you didn't assign it back to NBA, so nothing in the original NBA table changed. So if you wanted to get the result 4, let's call this table no position. And if you wanted to do that and find the number of columns there, that would be 4. Yeah, are there any questions about that? So just be careful when you're doing table function. For the most part, it'll usually make a copy of that table and create a new table. So you would want to refer to that new column name that you create, or that new table that you've created, rather than the original table. And if you think about it, it's actually useful that it doesn't just automatically reassign MBA to the dropped one, because what if you are doing like something very specific with only the salary, so you wanted to drop everything else, but then you wanted to do something else looking at the positions. You don't want what you've already done to carry over. Okay. I know this is a really long lecture, so bear with me. Does anyone have any questions? What do we do for B again? Yeah, so just to sum up, the answer for B is 5. So if you do MBA drop position and then do num columns again, you're actually going to get 5 because doing dot drop just made a copy of it and it didn't modify the MBA table. Yeah, so Eduardo asked a great question. What position has a higher average salary? So we'll be able to do additional table methods, which will help us find that. But for now, let's move on. So let's look at some census data. So every 10 years, the Census Bureau counts how many people there are in the US. And in between censuses, the Bureau estimates how many people there are each year. And from the Constitution, you can see written, we have representatives and direct taxes shall be apportioned upon the several states according to their respective numbers. So that's like kind of the purpose of the census starting with the Constitution many years ago. But really quickly, I also wanted to mention that in data science, we have to be mindful of biases that could be in every single step of the data analysis process. So there can be biases in how someone analyzes data, how someone draws conclusions, and also in the way the data is collected. And you can learn more about this in the human context and ethics class. I just wanted you all to be mindful that there could be biases in just the way the census data was collected. And I'm sure some of you know more about this than I do, but maybe in the chat, could someone think of a way that this census data could be biased? Yeah, it could be biased towards English speakers. Some people choose not to participate in the census. Some people might not have a phone or access to reliable internet, so they can't answer those questions. They might not even have a mailbox. So there's a lot of underrepresentation in communities that aren't able to complete the census. Yeah, so that's great. I mainly just wanted you all to kind of think about, while we're working with the census data, the potential ramifications of having biased data. Okay, so in these last 2 minutes, we're going to quickly go over some description for the tables and also some really quick demos. So we have these columns. So we have the sex column where 1 is male, 2 is female. This is from 2010. So that's why there's only like 2 values for the sex column. And then the pop estimate column for 2010 is based on the July 1st estimate. And then something that's kind of confusing for this is that some rows are sums of other rows. So for example, 1 is male and 2 is female, but the sex column that has 0 values is a total of all male and female counts, whereas the age column where it says 999 is a total of all the ages. And so numeric codes are often used for storage efficiency, and this is really common in these types of big data sets, especially in like sociology, stuff like that, to represent data in this way. So for example, if you're confused about what it means for the sex column to be 0, so if the sex column is 0 and it says the age is 10, that means that's the total of all people at the age of 10. And also if it says the age is 999 and sex is 1, that's all males of all ages, or yeah, all males of all ages. And then so the values in these columns will have the same type, but they're not necessarily comparable. So for example, you're going to have ages like 12, 13, 14, those are all comparable, but then we have that 999 in there, which isn't really. And that's because if you remember, like I said before, arrays have to all be of the same type. So if we wanted to include all the different ages, you couldn't also include the string total. That would have to be an integer. So that's why we have 999 there. And all this description is kind of confusing until you see the data. So let's just get into it. And so analyzing census data leads to seeing a lot of different interesting features. So going back to this, let's read in this full table. So a lot of these column names are like kind of bold and confusing. But basically, we have sex. So these are all the totals. And then this is the ages for everyone. And then the values in the rows are going to be the different populations for that grouping. So for example, if we're looking at 0 and 4 and Census 2010 pop, that's going to be all people of the age 4 and the number of people that was in 2010. Okay, so this table is really big. Let's just do something partially. Okay, so let's do partial is equal to full. And let's just select sex, age, census 2010 pop, and let's look at the estimate from 2014. So let's look at sex, age, then we want this, and oops, we want this. So let's look at what partial looks like. Okay, so this is what partial looks like. It's a little bit easier to isolate the values that we're looking at. But this column label is still really hard to work with because I like have to copy and paste that every time. It's not really that easy to type. So let's just do something else. So let's call this simple. We'll do partial dot. Okay, so let's say we want to relabel this column into 2010. How should we go about doing that? Oh, what does the 0 mean in column 0? That means, so if we see over here, 0 just means total of all male and females. And so that's all male and females at that age. So partial, yeah, I'm seeing relabeled. You could do 2 because this is the 0, 1, 2. So that's the second column. And then we want to relabel this to 2010. Let's look at that. Oops. So now you see that's been relabeled to 2010. And then it looks like some people are a step ahead of me. So we're also going to be relabeling this column. So that's 0, 1, 2, 3, and relabeling that to 2014. Okay, so now I think these are a lot easier to work with. So something we can do is, I know we haven't really worked with sort in this lecture, but does anyone remember how we can get, let's say we want ages in ascending order. How will we go about doing that? Yeah, simple.sort age. And so now you can see that's all people at the age of 0, all males at the age of 0, and all females at the age of 0. And then it goes back again to 1, so on and so forth. And then what if you wanted the largest ages first? How would we go about doing that? Yeah, you would add descending equals true. And so now you can see that's the total. So this is everyone in the this is the entire population. So that's total sex and total ages. And then this is all males of that age. Yeah, all males of all ages. And then there was a question up above that I thought was a good question. Would it error if you relabeled to just 2010 without quotes? Let's try that. 2010. Yes, it would error because we want the names of columns to be strings. Okay. Does anyone have any questions? Okay, and then let's see. Sorry. Yeah, we're going to be using relabeled and not relabel. So add the ED. Okay, so like I mentioned earlier, this 999 thing is kind of difficult to work with. So if we want to define like the average age or something like that, it'd be a little bit harder because we have that 999 there. So that would really throw things off. So if we wanted to exclude that 999, how will we go about doing that? Yeah, there are a couple ways. So we would want to do simple. And again, we're looking at only rows that are going to be below 999. So we could use where age are below 999. And that'll give you all those values. And then we can double check that that works by doing the same sort thing. And you can see when we sort, the ages at the top are 100 and there's no more 999. So we can see that that worked. Okay, so there's only 1 more minute left of lecture. So I'm gonna just go back to this slide and see if there are any questions. What is right below 999? That's a great question. So we saw here, if we sorted right below 999 is ages of 100 and then goes to age 99. So when we do age are below 999, it goes all the way up to 100, but it no longer includes 999. The where conditions, yeah, so that's a great question. So that's because if you don't add a condition, it'll automatically check if it's equal to that value. But there's a lot of other conditions that we want to look for. So if we want to look for, something that's below or equal to a value, something that's above, a string that's contained in the value. There are a lot of different conditions we can check for, so that's where these come in handy. What's the difference between take and .item? So take is going to take only a row of a table, and .item is going to take an item from an array. So let me scroll all the way back up to when we were working with arrays. So you can see here, we got the 0th item from this array, whereas take does a similar thing, but it's going to take a row from a table. Okay, so it is 12, so I'm going to stop recording.